When we look up at the night sky, the stars seem eternal. Generations have come and gone under their steady glow, and it's easy to imagine that they will shine forever. But the truth is far more sobering. Stars are mortal, galaxies evolve, and even the universe itself has a future that may end in silence, darkness, or something stranger. This is the story of cosmic endings. What happens when the stars go dark? And what does that tell us about the ultimate fate of everything we know? The life cycle of stars. To understand how the universe will die, we must begin with the lives of stars. Stars are born in clouds of gas and dust, collapsing under gravity until nuclear fusion ignites. For billions of years, they shine by fusing hydrogen into helium, releasing energy that pushes back against collapse. But fuel doesn't last forever. Small stars like our Sun eventually swell into red giants, shed their outer layers, and fade into white dwarfs, dense stellar embers that slowly cool over trillions of years. Massive stars burn brighter and die more violently, exploding as supernovae and leaving behind neutron stars or black holes. Each ending scatters elements into space, seeding future generations of stars and planets. On cosmic scales, this cycle of birth and death has kept the universe vibrant for billions of years. But cycles depend on raw material, and eventually, the supply runs out. A universe running out of fuel right now. New stars still form in galaxies, fueled by clouds of hydrogen gas. But the supply is dwindling. As gas is locked into stars and stellar remnants, less remains for new generations. Astronomers predict that in about 100 trillion years, a time span unimaginably longer than the current age of the universe, star formation will cease. No new suns will be born. The galaxies will slowly dim as the last stars burn out. The universe will transition from the stelliferous era, the age of stars, into something darker. The degenerate era. When the last stars fade, the cosmos will be populated mostly by stellar remnants, white dwarfs, neutron stars, and black holes. White dwarfs will cool into black dwarfs, cold, dark, lifeless spheres. Neutron stars will spin down, their energy spent. Black holes will lurk in the dark, swallowing stray matter but growing ever more isolated. The universe will be a graveyard of stars, filled with remnants that glow faintly, then fade. This era, stretching far beyond anything we can truly imagine, will be the twilight of creation. Black holes and Hawking radiation, but even black holes are not eternal. Stephen Hawking showed that black holes slowly emit radiation, a quantum process now called Hawking radiation. Over unimaginable spans of time, black holes will evaporate. Small ones go first, in bursts of final energy. The largest, those at the hearts of galaxies, may take 10 to the power of 100 years or more. That's a 1 followed by 100 zeros, so vast a number it defies comprehension. Eventually, even the black holes will vanish, leaving only particles drifting in an expanding void. The heat death of the universe. This brings us to the most widely accepted scenario, heat death. As the universe expands and matter becomes more thinly spread, energy differences even out. Thermodynamics tells us that systems evolve toward equilibrium, where no useful energy remains to power change. In heat death, the cosmos reaches maximum entropy. No stars, no black holes, no gradients to drive structure. Just a thin, cold mist of particles expanding endlessly. It is a bleak picture. A universe that doesn't end in fire, but in silence. Not with a bang, but with eternal emptiness. Alternative fates. The Big Rip. But heat death is not the only possibility. The fate of the universe depends on dark energy, the mysterious force driving cosmic acceleration. If dark energy grows stronger over time, the expansion could accelerate without limit. Galaxies would be torn apart, then solar systems, then planets, and finally atoms themselves. This scenario is called the Big Rip. If true, the end could come in as little as tens of billions of years, a flash compared to heat death. Alternative fates. The Big Crunch and Big Bounce on the other hand, if dark energy were to weaken or reverse, gravity could regain control. Galaxies might slow, then collapse back inward. The universe could end in a big crunch, collapsing into a dense state, perhaps even giving birth to another expansion, a big bounce. Most current evidence points toward continued expansion, not collapse. But cosmology has a way of surprising us, and future data could change the picture. Echoes in today's universe, though these endings lie unimaginably far ahead, hints of them exist today. We already see galaxies slipping beyond our cosmic horizon, carried by expansion into invisibility. We observe stars burning their fuel, knowing each one has a finite life. We study black holes and their slow evaporation, glimpsing the mechanisms of the far future. In every supernova, every fading star, every measurement of cosmic acceleration, we see echoes of the universe's destiny. Philosophical reflections. The death of the universe isn't just a scientific question, it's a philosophical one. What does it mean to live in a cosmos with an expiration date? Does the prospect of heat death make existence meaningless, or does it make every moment more precious? Some thinkers suggest that cosmic mortality humbles us, reminding us that permanence is an illusion. Others argue that meaning comes not from eternity, but from what we do with the time we have. And perhaps the end is not truly an end, but a transition into forms of existence we cannot yet imagine. Why it matters today, you might wonder. Why think about events that will happen trillions of years from now? The answer is that contemplating cosmic endings expands our sense of scale. It reminds us that we are part of a larger story, one that stretches from the first stars to the last. Studying the fate of the universe also sharpens our science. By measuring cosmic expansion, dark energy, and the life cycles of stars, we learn not only where we came from, but where we are going. And ultimately, these questions remind us of our fragile place in the cosmos. The stars may not last forever, but for now, they shine. And in their light, life has found a way to ask these questions. When the stars go dark, the universe will be a different place. Whether it ends in heat death, a big rip, or a cosmic bounce, its story will continue beyond us. We may never witness those distant futures, but by imagining them, we take part in the greatest act of human curiosity, seeking to know not just how things are, but how they will be. And as we look up at the stars tonight, glowing steady and ancient, we can remember, they, too, will one day fade. But in the brief cosmic moment we share with them, we are part of their light. And that light, however temporary, is beautiful.